Welcome to the Best Robotics CDR presentation. First off, just as a reminder, all of these presentations will be found in the Best National Registry as well as on the Google Slides folder that is sent out to your teams. The Best National Registry is super important, so make sure that everybody on your team is signed up and has an account. So critical design review, a CDR, is a very important part of any engineering process. But first, another reminder, you have to register for a time slot in order to actually be able to compete. So everybody has to do a CDR. It is just as mandatory as the notebook, and so everybody has to sign up to do a specific time slot. So a little bit of an overview as to what we're talking about today. What is a critical design review? Why is it important? How you are evaluated? How to create a CDR? How to get help? And the 2021 schedule. So the goal of a CDR is to take the ideas and preliminary plans for a design and turn it into analysis and corresponding plans as to actually build the product. A CDR is the jumping off point from what you do in the design phase versus the building phase. So everything leading up to the building phase is discussed in a CDR. So why are CDRs important? They provide a landmark for your project, so they provide basically a goal for you in order to see how close you are to solving the problem, whether or not you're capable of actually doing what you say you're going to do in the design phase. And in the case of CDRs for investors or management, it illustrates that you are actually worth the resources that it takes to build your product. In addition, it also solidifies plans for future work. And like I said, in a real company, it gets you funding. But only if you can prove it will work by your deadline. So the engineering design process is based in 7 steps. Understanding the problem, like reading the rules, determining requirements, researching similar designs, inventorying resources available, like your kit. And then concept and exploration and selection is brainstorming strategies and designs. It's coming up with the ideas, throwing spaghetti on the wall and seeing what sticks. And analyzing and prototyping. So the CDR is not before you build anything. You have to build some stuff to prove your concept works. But once you have figured out that your CDR, that your concept is viable, then you build a CDR based off of the analysis, the prototypes, and your schedule plans. And then after the CDR is where you move into detailed design and manufacturing, integration and testing, and repeating as you need. So if something turns out that it won't work, maybe you have to go back up to step number 3 and prototype a different solution. That's just as important as getting something correct in the first place. And then at the end of this whole process, you deliver the product and you prove that your solution actually works, which in our case would be game day. So what is a requirement? A requirement is going to be the basis that you build everything around. It's what is the customer looking for? In your case, it would be the size of the robot. It can't exceed a certain size, and it can't exceed a certain weight. And requirements are typically discovered. So what does it need to do? Analyzed. How well does it need to do it? Documented. So that would be like the rules in our case. And verified and validated. Are we building the right thing? So are you doing the thing that is required of the game? And are you building that thing correctly? So a couple of examples. The product should be able to do action 1. Action 1 is essential to the success of the mission, and action A is a pivotal part of our strategy. The product shall be able to do action 2 without violating constraint A. Constraint A is given by the customer and is a non-negotiable item. Action B is another important part of our strategy, but risks violating constraint A. So with like the actual height requirements of the robot, if you have an arm that extends or does something of the sort, you have to make sure that you are not in violation of the rules surrounding extension past the base size. The product shall be able to do action 3 despite constraint B. Constraint B is an unavoidable limit to operations but is workable. So that's kind of like the fact that you only get so many items in your kit, and once you use that, you're done. And action C must be done within the window of constraint B, as it is a valuable addition to our strategy, which is difficult but workable. So staying within the kit and being able to use what you have and not go past it. An example of design alternatives and pros and cons. The product shall be able to do action C despite constraint B. Solution A can do action C with relative ease. That's a pro. Performing action C severely risks violating constraint B. So, and it just continues on. And it's important to note that all of these pros and all of these cons have different weights to them. And so sometimes violating some constraint is better than violating another constraint. And that's part of your analysis. So A trade study is basically weighting possible solutions and coming up with which one has the highest score and is the most viable. And as long as all solutions are rated objectively on the same scale, it should work out for you. As I said before, assign each trait a weight. A multiplier, this is a multiplier representing importance to the designers, and multiply scores by their weight. Notice that all weights add up to 1 above. The total the weighted scores for each design and then compare the values. The highest score is the most optimal solution according to your scoring scale. If something does not seem like it's right, it probably isn't. So make sure you're double checking your math and make sure you're going through stuff and adding things correctly. So the weight scale is part of the risk assessment and lessons learned. So in your risk identification, you have to ask what can go wrong and what might keep your project from performing ideally. And there are other questions that you can ask as well, and you just have to come up with those yourself. And then risk evaluation, where do these risks come from? How likely are they to occur? Risk treatment, how can you mitigate these risks? How can you either make them less likely to happen, or how can you make it so that even if they do happen, it's not the end of the world if they do. And then risk monitoring and review. Are the risks becoming more likely over time, or more or less likely over time? Is there anything you and your team can do differently to mitigate risks more effectively? So that's constantly making sure that you are actually checking and monitoring the risks, and maybe those risks change depending on how the game field changes, or any number of things. So an example, the CDR is not ready to be presented on October 31st. And continuing along into risk evaluation, the CDR presentation has not been started as of October 10th, and no one has been assigned to create the CDR presentation. Just a side note, it's probably not a good idea to wait until the end of October to make your CDR, because you should be able to do this as you go. And then risk treatment, establish a plan and a schedule. If you notice, these steps kind of follow the engineering design process. So you're identifying the problem, you're identifying requirements and constraints, and then you're coming up with solutions, and then you're reiterating and continuing to do so. So for the judging procedure, it's really, really important to make it as easy as possible for the judges to find the categories in your presentation. So the easiest way to do this is to set it up via slide titles. So, specifically like analysis. If you have specific analysis that goes with the score sheets, you should have slides that say analysis or weighted matrix or stuff like that. The CDR score specifically is judged for an independent award. It does not affect your best award, but as you are going into engineering and learning how to do this, even if you're just taking courses in college, CDRs are very common. And it's very important that you are able to do them and that you are prepared for the future. That is honestly one of the goals of Best Robotics. So I can't stress this enough. Read the competition rules. All of these specifications, all of the rules about CDRs, everything that you need to know about what needs to be in your CDR and what you need to do for your CDR is in the rules. So each group will be allotted 25 minutes, 20 minutes for the presentation, 5 minutes for the questions of the judges. Don't rush through it, but don't have too little content that you have 10 minutes that you are just standing in silence. And practice. Practice, 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 practice. It is so important that you practice your timing and that you know your content, and it will help give a more professional presentation, and it will help you feel more confident in the presentation in the first place. Teams should be expecting detailed questions about your design and about your decisions. And it's just important that you do your best, and it's not your parents or your mentors or anybody else doing it. It is you as a student. And finally, make sure that your slides and content are readable and organized. So you don't want text that is so small that nobody can read it, and you don't want pictures all over the place that nobody has no idea what they're looking at. So Scoresheet sections, there's the requirements for 20 points, functionality for 30, design specifications for 30. And tips, once again, make it easy for judges to find evidence of each criteria, provide specific examples of brainstorming and analysis and testing, follow the structure of the score sheet. It's basically an outline for you. So, and if you miss a section, you won't earn points on there. So make sure you have everything that the score sheet requires. And here are some screenshots of the actual score sheets. But if you read the rules, you shouldn't need them off of this slide or this one. So now let's talk about how to actually make a great CDR. Using the engineering design process as a even further outline. So it should go score sheet, outline, or score sheet as the outline, and then engineering design process within that outline. Don't wait till the last minute on doing this. I know it's so tempting to just put it off because you want to make sure that the robot works. But if you don't have this, it won't matter if the robot works because you won't be able to compete. And practice. Practice, 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 practice. Make sure that your presenters know who they are, know that they are presenting and know what they are presenting on, and schedule times to go through the presentation and practice. So elements of the engineering design process can be found on the left, and then designing the critical design review is on the right. It's important that you know what the project's purpose is and specific objectives that you must achieve in order to achieve the purpose. And everything kind of falls under identifying the correct purpose in the first place and moving forward from there. So there are examples from CU Boulder's Aerospace Engineering class of 2020, and they had to present these to prove that they were ready to build their assigned projects. And some of the projects are super cool, and you should definitely take a look at them for examples of how to do a CDR. And how to stay on top of the CDR. Don't procrastinate. I know I said it before, but don't wait till the last minute. Fill in what you can. When you do brainstorming, take pictures, type up the brainstorming slides. Make it so that you are doing a little bit at a time. Make a plan. Just like you make a plan to build the robot, make a plan to build the CDR. And if your team has a master schedule, make sure that the CDR is on that master schedule. Try and present to an audience of adults. Make it so that your parents and your teachers and your mentors sit through the presentation with you as you're presenting it and act like you're presenting it to judges. And it's as close as you're going to get to the real presentation. The judges are not going to listen to you present it ahead of time, so don't even try. Please, please, please check the Best National Registry for key deadlines, hub logistics, and due dates. Super, super important. This is a recording, so if you have any questions, send an email, and thank you for listening.